Let's start reviewing for our final. So review for Calc 1 final. This is basically comprehensive. So we're going to start with integration, which is the most recent information. The first question that I have is e to the x over e to the x plus 3 dx. And we need to integrate that. It does not have any bounds, so we don't have to worry about that part. But anyway, let's do this with substitution. So let's let u equal something that's a little more complicated. Let's take the denominator. So e to the x plus 3. Du then is the derivative of e to the x, which is e to the x. The derivative of 3 is 0, so we put dx next to that. Notice the derivative is there, the u value's there, so our problem is du over u, which is something that is fairly recent. 1 over u du, its integral is the natural log of u plus c. And finally, we need to back substitute. So ln of e to the x plus 3 and then plus c. Now, if you want to, you could take e to the x plus 3 out of the absolute values because it's e to the x is always positive. Add 3, it's always positive, so you don't have to worry about the absolute value. Now, the next problem I have is this one. It's got the secant squared of x times the tangent of x dx. There are a number of ways to do this one, substitution being the main situation. So the suggestion that I have here is to let u equal the secant of x. Now it will actually work if you let u equal the tangent of x. Your answer will look slightly different, but the plus c makes up for it. So if u is secant of x, then du is equal to the derivative of secant, which is secant x tangent x dx. Now notice we've got secant and then we've got secant tangent dx. So what we've got is we've got u and then we've got du, because these two multiplied together give us secant squared tangent dx. So here's our result of the substitution. Do the reverse of the power rule. You get u squared over 2 plus c. U is the secant, so secant squared of x over 2 plus c. Now, if you happen to do that with u equal tangent x, like I said, it'll look slightly different, but it won't equal anything different. Okay, I'm going to grab the third question here, and the third question is this one. It's the integral of the cosine of 3x divided by the square root of 5 plus 2 times the sine of 3x, and then dx. So, substitution once again. Take the more complicated piece. That would be something from the denominator. Now, I don't always like to take a square root for a substitution because it kind of perpetuates itself. So let's take the stuff under the square root and let u equal 5 plus 2 sine 3x. So then du is equal to the derivative of 5, which is 0, 2 times the derivative of sine 3x. This is a chain rule problem, so it's cosine 3x times the derivative of 3x, which is 3. And then dx. So we have a total of 6 times the cosine of 3x dx. Well, we need cosine of 3x dx. We do not need 6 cosine of 3x dx. So the key to that is to divide both sides of this by 6. So we get cosine 3x dx is equal to du over 6. Consequently, our problem is this. It is du over 6. I'll put that there. And then we've got over the square root of u, which we can't really do officially, so we've got to turn this into powers. This is u to the minus 1/2, minus because it was in the denominator, 1/2 because of the radical, and then du. So we've got 1/2, or 1/6, excuse me, 1/6, raise the power 1. So you've got u to the minus 1/2 plus 1, which is plus 1/2. Divide by the new power. So dividing by 1/2 is just exactly the same thing as multiplying by 2, multiplying by the reciprocal, and then adding c. So now we've got this. We've got 2 over 6, which is 1/3. We've got the square root of u. U to the 1/2, square root of u. Well, here's u. So let's back substitute while we're at it. We get 5 plus 2 sine 3x, then plus c. So there's how our answer will turn out. Let's try another one. This one has boundaries. So this one is minus 2 to minus 1, and it is u to the minus 4 plus 3u to the minus 2 minus 1 over u to the 5th du. Notice these all match. They have to. And we've got boundaries. These are all to powers. This one can be made that way. So let's do this. Let's just do this as a standard problem. We've got u to the minus 4 plus 3u to the minus 2 minus u to the minus 5. Just pull that up as a power and then go after it. So we now have to raise the power of each and divide by the new power. U to the minus 4 becomes u to the minus 3 divided by minus 3. Plus 3 times this one, add 1 to the power, you get u to the minus 1 over minus 1. And then this one, I changed it a little bit, is minus, and then u to the minus 4, because I'm adding 1 to the power, divide by minus 4, and then plus c. So if I put those in a way that I can deal with them a little better, actually I don't want plus c, do I? Because this is a definite integral, so let me get rid of that. Let me put these in a little easier form and then run the fundamental theorem of calculus. So we've got minus 1 over u, we've got a 3 there, u cubed, okay? Then this one's minus 3 over u. The 3 is unaffected by the power here, so 3 over u. And then we've got minus here, that is plus. We've got 1 over 4u to the 4th. And this has to go from minus 2 to minus 1, so we evaluate at minus 1 first. Minus 1 over 3 times minus 1 cubed. Minus 3 over minus 1 plus 4, or 1 over 4 times minus 1 to the 4th. Then we have to subtract this stuff at minus 2. Block it off. You have to, so you don't get messed up with the minus sign. So we've got minus 1 over 3 times minus 2 cubed, minus 3 over minus 2, plus 1 over 4 times minus 2 to the 4th. Okay, so now let's calculate. We have minus 1 to the 3rd, that's minus 1. So that minus 1 and this minus 1 cancel. We've got 1/3. Don't lose track of where those are. This one, the canceling of these minus signs is pretty nice. So we've got plus 3. Then minus 1 to the 4th is plus 1. So we've got plus 1/4. Then we've got minus. Now, minus 2 to the third is minus 8. So this minus and this minus will cancel. But we've got 1/24. So 1/24. And the minus is canceled. So there you go. And then minus and minus. So this is plus 3/2. Minus 2 to the fourth is 16. So we've got 1/4 times 16, which is 1/64. So there's our problem at this point. Now you may or may not like to do fraction work. I'm going to kind of cut some corners on that. So let me get my calculator going here. Let's see what happens. Here's the calculator. And let me set it right here and I'll kind of grab the numbers. So I'm going to take 1/3 plus 3 plus 1/4 and then minus 1/24 minus 3/2 and then minus 1/64. Minus 1/64. Hit enter. That's fun, you know, but hit math, enter, enter, and that gives us 389/192. So 389/192. So there's a really nice looking answer, okay? So that's where we are at that point. Now, let's see what we come up with next. The next problem I have is a word problem. And it says that the acceleration for a function is given by a of t equals t plus 5. The initial velocity, so initial velocity is v of 0 equals 15. Initial position is s of 0 equals 5. And the question says give both the velocity and the position functions. Well, if you'll remember, if you've got position, that's s, its derivative is velocity, that's v, and velocity's derivative is acceleration. So let's go backwards. The velocity function based on t is equal to the integral then, we're going backwards, of t plus 5 dt. So I get the reverse power rule gives me t squared over 2. Take the reverse power rule of 5, that's 5t to the 0, so this is going to be 5t to the first. So this is my velocity function. I've got plus c though. Or you could actually say plus some kind of a velocity constant. Now, v of 0, take a look at this. V of 0 is equal to 0/2 plus 5 times 0 plus c equals 15. So there's c. So v of t is actually equal to t squared over 2 plus 5t plus 15. So now we take the velocity function and we integrate that to get the position. So t squared over 2 plus 5t plus 15 dt. So raise the power one more unit. We get t to the third. We got to divide by 3. It's already divided by 2, so this is 6. 3 times 2. 5t squared over 2 plus 15t. And then I've got to have another constant, so I'm going to call this one c sub 1, so I don't get them mixed up. Now, I've got to put the initial position, so s of 0 is equal to, this is 0, this is 0, this is 0, so I'm going to end up with c1 is equal to 5. So there's my initial position. So my position function is t to the third over 6 plus 5t to the second over 2 plus 15t plus 5. So we've answered the initial position, the actual position, the initial velocity, and the actual velocity functions. All right, let's go to some derivatives. We've done a little bit with integration. Let's do some derivatives. So my next problem is this one. F of x is equal to x to the minus a half plus 1/9 x to the plus a half. Now, first question is find f prime of x. So hopefully this is easy by now, but these are both power rule problems. So I take the power minus a half, x, lower the power one, minus 3/2. This one, 1/9 times the power, so that's 1/18. X to the lower the power by 1 unit, get minus a half. So there's the first derivative. Now, second derivative. There's really no shortcut. I have to find the first derivative first. So derivative of the first derivative is the second derivative. We take minus 3/2 times minus 1/2. That's positive 3/4. X to the lower the power 1, so we've got minus 5/2. Then we've got minus a half times 1/18, so that's minus 1/36. X, lower the power 1, minus 3/2. So there's the second derivative. Now, what's the next problem? Let me see here. I gotta figure this out. Okay, what are the critical values? So critical values. If you'll remember, critical values are found from the first derivative, only from the first derivative. We set it equal to 0 or undefined. So let's write this in fractions. So we've got minus 1 over, I'm going to do this, 2, and then take the negative exponent and stick this stuff down below, so I've got x to the 3/2. Then here I've got plus 1/18, and then this is x to the 1/2. Okay, so we've got to find out where that's either equal 0 or where it's undefined. Well, I would suggest to you that it's undefined in a very easy spot. It's undefined when x is 0. So it's undefined if x equals 0. Now, where is it equal to 0? Well, let's find out. Set this equal to 0. And then we can multiply by the least common denominator. Well, between 2 and 18, we'd have to have 18. Between x to the 1/2 and x to the 3/2, we'd have to have x to the 3/2. So if I take 18x to the 3/2, multiply by 0, and then 18x to the 3/2 times all of this stuff, minus 1/2x to the 3/2 plus 1/18x to the 1/2, I will get, okay, the x to the 3/2 cancel, 18 and 2 cancel, so we get 9, so we're going to get minus 9. Then we're going to get plus, the 18s cancel, 3/2 power versus 1/2 power, that's going to be 3/2 minus 1/2, which is 2/2. So 18x to the 3/2 times 0 is 0. This side's equal to minus 9 plus x, so x must equal plus 9. So we've got two different critical values. X is 0, x is 9. Now, if you need critical points, you have to plug them in the original problem. But the question asked for critical values only. So we can do that. Now, what are the inflection values? How about inflection values? So inflections. Take the second derivative. They only come from the second derivative. So we set that equal to 0 and or undefined. So let's check that out. It's 3/4, so 3/4. This is x to the 5/2 in the denominator, so I'm going to do this. Minus 1/36. This is x to the minus 3/2, so it's going to be x to the plus 3/2 in the denominator. So pretty clearly, maybe, x equals 0 makes it undefined, okay? So that's something we can set up. The second thing, set it equal to 0. So 0 is equal to this. Take the common denominator, least common denominator. So that's basically the biggest of the things that we have, or the bigger. So 4 versus 36, we're going to use 36. X to the 5/2 versus x to the 3/2, we're going to use x to the 5/2. We're going to multiply that by 0, which is going to give us 0. And then we're going to multiply it here. So 36x to the 5/2 times all this. So 3 over 4x to the 5/2 minus 1 over 36x to the 3/2. Okay, so where are we going with that? We need to continue multiplying this out. So let's do that. We've got this. We've got 0. Now 36 over 4 is 9. X to the 5/2 over x to the 5/2 is 1. So 9 times 3 minus 36 over 36 cancels. X to the 5/2 over x to the 3/2 leaves us with x to the 2/2 or x. So we end up with 0 equals 27 minus x. Consequently, 27 equals x is the other inflection value. So we've got two inflection values. Okay, so that's where we are there. Now let's see what else we've got to do with this. Got to move my paper up here a little bit, see the next question. Okay, so I've got to get relative max or relative min. To get relative max or relative min, I've got to use the critical values. So I'm going to mark this. So max and min. So I'm going to do my critical values. My critical values are 0 and 9. So 0 and 9. I need to choose some test values, something to the left of 0. Now take a look at this. These guys have square roots. So there is nothing to the left of 0. So we will start our situation there. This is not defined. It's not in the domain. So we don't even have to consider that. So between 0 and 9, well, I'm going to have a test value of 1. Here, test value of 10, just to get an idea. Actually, since these are square roots, I'm going to change this. I'm going to have a test value of 16. You can have better answers, or easier answers to look at. So f prime of 1. So what is f prime of 1? Well, it's equal to minus a half times 1 to the minus 3/2. Well, 1 to a power is 1, so there's that. And then plus 1 over 18 times 1 to the minus a half. So essentially we have minus a half plus 1 over 18. Minus a half plus 1 over 18. Well, minus a half is minus 9 over 18 plus 1 over 18, so that dude is negative. So we've got decreasing. Okay. Now 16. Let me try to cram it in this page here. So f prime of 16 is minus a half times 16 to the minus 3/2 plus 1/18 times 16 to the minus 1/2. Well, 16 to the minus 3/2. Let's check that out. The 1/2 power of 16 is 4. 4 to the third is 64. And a negative exponent makes it 1 over 64. So we've got minus a half times 1 over 64, which is minus 1 over 128. That's a pretty small number, and it's negative to boot. Now we've got this one, 16 to the minus a half. So 16 to the 1/2 is 4. That's the square root. Negative power makes it 1/4. So 1 over 18 times 4, that would be 1 over 72. 1 over 72. So this one is bigger than this one. So this is positive. So this is positive, so it's increasing. So it decreased and then it increased. This is a relative min. Okay, so we didn't have a relative maximum yet. We've got to check something else out. Could you put 0 in there? No, you can't. I should have put a bracket, like a parenthesis, as you can't put 0 in. It's undefined. So there's really no relative max. There's a relative min. Relative min at 9, at x equals 9. Now what is the relative min? Well, we put it in the original function because that's where the points come from. So if x is 9, 9 to the minus a half. The 1/2 power makes it 3, minus power makes it 1/3. So we've got what, 1/3? So 1/3. And then we've got plus 1/9 times 9 to the 1/2. So that's 9 to the 1/2 is 3. So 1/9 times 3 is 1/3. So 1/3 plus 1/3 is 2/3. So y equals 2/3. So there's a relative min. No relative max. We did not have a relative max. Okay, let's continue on with another one in a few minutes.